Here we are going to learn about insertion in a doubly linked list. So let's see. So for a doubly linked list, so first we will look at the structure of a node. So each node in a doubly linked list, so it has three parts. First is the data part. So you have some data, it could be int data, it could be char data or anything, okay, a collection of things also, okay. So we have an integer in each of the nodes. Then we have two other parts. First one is the address of the previous link or the node and the address of the next node. So total a node has a data, then the address of the previous node and the address of the next node. So it tells us that it suggests that we can move both forward and in the backward direction in a doubly linked list, okay. Then what we need to do is maintain a head of the linked list. So the head of the linked list stores the address of the first node. So the thing is, if we have the address of the first node, then we can traverse the whole linked list, because through the first node I come there and I can find the address of the next node. I go to the next node and then I can find the address of the third node in the second node and so forth. So this is about the structure of a node. Then let's look at insertion in the beginning of a linked list, okay. So let's try to understand. So we have insertion in beginning of the doubly linked list. So there might arise two different cases, okay. So the first case is that, okay, let's have a linked list where we have no element at all. So there are two cases. A doubly linked list is empty or doubly linked list has some elements. So if it is empty, so what happens is, then we will just find it by using isHead is equal to null. If it is so, it means it's empty. So then what we do, we use a malloc function. So you can see the code here. So we use, so the insert at first is the name of the function, and we have the argument is the key that we want to insert at the first place. So if head is null, so this is the case when the linked list is empty. So this is for empty linked list, okay. So this is empty linked list. So we have empty linked list. So then what we do, so we make head itself point to a memory location that we get by calling malloc function. So malloc is basically for memory allocation, and we say that, okay, please give us a memory of size of node, struct node that we saw, that of the structure, and it returns us a memory which is of void star. So we typecast it to node star type, and then what we do, so now our list head was like this, so it becomes something like this, okay. So it has these two pointers which are dangling now. So what we do, head data is equal to key, so we put the key in the data part. Head previous, which is this one, I make it equal to null, and head next I also make it as null. So this is my doubly linked list now with one element inside it. So head is pointing to that, and its previous and next node are null. But let's see the case when the linked list was not empty. So in that case, what will happen is, we will have something like, let's assume we already have some elements in our linked list, okay. So let's say that we had got 3 elements in our linked list. So what happens is, this is the start, and now what we want to add one more element to a non-empty linked list. So we will again, what we do, we make a temporary pointer like this, and we get memory for that. So we have this a temp variable we make, and for temp we get the memory of the size of struct node, and we put some data in it, the key. Then let's see what we need to do. We need to have the proper connection. So head is now pointing to, let's say 1, 2, 3, and now I inserted an element, let's say 5. Okay, so now I want to make 5 as the first element in the linked list. So what will happen is that till now it was like this, but now somehow I have to make this as the first element. So what I need to do is make temp next as head. Then we need to make temp head is this one, so head previous as temp. So these two connections are now fixed, so that is temp next is head and head previous is temp, and now head should be made equal to temp. So head is made equal to temp and this connection is broken. So now head is pointing to this one, so it becomes something like, now it is a 4 element linked list. Head is here, so it is 5, then 1, 2 and 3. Okay, so this is the doubly linked list now with the proper connections. Okay, so let's understand the function now. So insert at first, so first case was what? If the head was null, so we made head is equal to node star, so malloc, I got the memory, then head data I put it as the key, and then head previous is null and head next is null. So this is simple, but the else part is when there is a non-empty linked list. So it was something like this, there were some element here. Okay, so there were some element, and now so temp I made struct node start temp I did, and temp is equal to malloc size of node I did, so I got one element like this. Okay, and then what I did, temp data is key, so I filled that key, and then temp previous, so temp previous is null, the temp previous is null, temp next I made equal to head, and head previous I made equal to temp, and then head I made equal to, so this temp. Okay, so this means, so my linked list is now insert at first is done. So here we had missed one thing, so that was this temp previous should also be made as null. Okay, so this was about inserting at first, but let's see what happens if I have to insert at end of a linked list. Okay, so end of a linked list, so what happens is we have now, instead of at first position, I have to put my element at the last position. So what will I do again? If the linked list is empty, so it's trivial, so first and last inserting in the beginning and inserting at end will be similar to this case. But if it is in the end I am inserting, so I will make struct node start temp is equal to head I do. Okay, so it means I will have a temporary pointer which is pointing to, so this is temp, now this is equal to head, so it means temp also has the value 0x35. so these are the memory locations, and here we have as in doubly linked list, so head previous is null, so it is 0, head next is the memory location of the second element, so it's 0x27. For the second element, the first node is its previous, so for the second its previous is 0x35, and for the second its next is the third element which is 0x71. Okay, so what we do, we make temp is equal to also head, and now we do a traversal which we do like this, while temp next is not equal to null, so we do temp is equal to temp next. So while temp is this one, then temp next is this, so while temp next is not null, so temp next is not null because it's pointing to a valid node, and its address is 0x27. So it becomes temp is temp next. So temp now points here. So temp becomes now 27. So it is 27. And now again it checks, is temp next, which is 0x71, is it null? So it's not so. So it makes temp is equal to temp next. So temp become now 0x71, and pictorially it points here. Okay. So after this, again the while loop runs and it checks, is temp is equal to, is temp next null, and it finds that yes, it is null. So it stops. So by these two lines of the code, we find that we come to the temp points to the last element of the doubly linked list. So then what happens? So then we make another node. So struct node star temp2 equal to node star malloc size of node. So this, what it does is that we get temp2. So temp2 here is something like this, and we malloc it. So we get some node and its memory, let's say, is 0x83. Okay. So now what happens is we get temp2, which is this one. Okay. So this is temp2. Now let's see the manipulations. So temp next is temp2. So temp next was now null. So now it is made equal to temp2. So this becomes equal to 0x83, and hence this temp next now points to this one. Now let's see. So temp next is temp2. Temp2 previous is temp. Temp2 previous is this one. It becomes equal to temp. So this connection is also made. So now temp2 next is null. So temp2 next becomes null. So this is 0x00, and then this previous becomes 0x71, and then let's see. So temp2 data is key. Okay, so temp2 data is equal to key, so whatever we passed. So now we see that a connection is made, and this is insert at end. Okay, so this was about insert at end, and this code we can see the demo of the code also.